Hello students, in this video we are going to see bonding in complexes based on VBT concept. So let's see the first example. Here if you see the molecule, cobalt is the metal and amine is the ligand which is attached to it. So depending upon the complexes, let's first write down some basic things about the complex. So the first thing what is important is the atomic number of the metal. So here the metal is cobalt, so its atomic number is 27. Second thing we will write is its electronic configuration. So its electronic configuration will be argon 3d7 4s2. Third important thing students, if you see the complex, the metal is attached to 6 ligands and therefore the coordination number here of the metal is 6. Then you have to analyze the strength of the ligand. Amine is a strong ligand, so the nature of the ligand is strong. And very important last thing, you have to find out the oxidation number of the metal. So let's find out the oxidation number. Amine being neutral, so its contribution here, this is 0. Let us find this cobalt, take it as X plus is equal to, the total charge should be equal to the charge on the complex, so it is 3 plus. And therefore the oxidation state for cobalt here is plus 3. So the oxidation state is plus 3. Now let us start for the VBT concept. The first very important thing what you have to write is the ground state electronic configuration of cobalt. So cobalt in the ground state. So let us write the electronic configuration 3d7 4s2. So I will draw the d orbitals. Now students, if you see the number of ligands, they are 6. So I will be requiring 6 vacant orbitals for the ligands to overlap and therefore I should have 6 orbitals. So keeping that in mind, I am taking the 4p orbitals also, but I will keep them vacant as it is. So let us fill the electrons now. You have to follow Hund's rule while filling the electrons. So I am filling the electrons in the d orbitals in this way. This is 3d7 4s2 and this we kept it vacant. Next is you have to write the electronic configuration of cobalt in its plus 3 oxidation state. So what will be the electronic configuration student? You have to remove 3 electrons. Now how to remove the 3 electrons? So the electron removal process will be 1, 2 and this electron. So let us remove the electrons now and write the electronic configuration. So it will be 1, 2, 1, 1 and this is removed and this we will write. So this is your 3D, this is 4S and this is 4P. Now this is the electronic configuration of cobalt in plus 3 oxidation state. Now students, when the ligand they approach this metal ion, so what will happen is this amine being a strong ligand, the pairing of the electrons will take place in d orbital. Now how the pairing will take place student? This electron will pair up with this and this electron will pair up with this. So let us write the electronic configuration after pairing. So electronic configuration after pairing will be, now why the pairing is taking place? Because the ligand is strong. So let us write the electronic configuration after pairing. So after pairing you will get two here and 2 here. Now this 3D is having 2 vacant orbitals. One from this S, if you see this is 4S and this is 4P. How many ligands we have student? We have 6 ligands in the complex because the coordination number is 6. So I require 6 vacant orbitals for amine to overlap. Now the first orbital will be this Second will be this. So I got D from here, D2. This is 1. So this will be S, and those 3 P. So it will be P3. Now I got 6 orbitals which are vacant. So what will be the configuration after the ligands they occupy the vacant orbitals will be this is the original of the cobalt atom ion, and now the first amine, second amine, third, fourth, fifth and sixth. So what is included here, students? This is D2sp3 hybridization. So those are the orbitals which are involved in the hybridization. Now students, if you see this, the inner d orbitals they are utilized here, and therefore this complex is called inner orbital complex. So this is based on the VBT concept, how the hybridization takes place. So let us see some of the properties now. So the geometry here for D2sp3 is octahedral. So let us see the first one. The geometry here is octahedral. Now what will be the structure of octahedral, students? For octahedral, if you see, the metal ion is surrounded by 6 ligands. So the expected geometry will be, you have to draw the metal at the center and draw the 6 ligands in the octahedral plane like this. Now if you see the complex will be surrounded like this in a square bracket, and you have to put a 3 plus charge on the complex because there is a plus 3 charge. So this is the geometry which is octahedral. Second important thing, students, if you see here, are there any unpaired electrons present? No, there are no unpaired electrons, and therefore the magnetic nature is, it is diamagnetic in nature. Why it is diamagnetic, students? Because no unpaired electrons present. Now next is, when you see the type of the ligand, what we have written, students, it is a strong ligand, and therefore being a strong ligand, we call this particular complex as low spin complex. So what we have now, the geometry is octahedral. What is the hybridization that this molecule complex undergoes is D2sp3 hybridization. Geometry is octahedral. Nature or the magnetic properties, it is diamagnetic, and a low spin complex where it forms an inner orbital complex. I hope you have understood the concept. So please do like this video, share it with your friends, and don't forget to subscribe to my channel. Thank you, students.